This assessment asks us how we could separate the enantiomers of phenylpropionic acid. Why is this a challenge? Well, these two molecules, being enantiomers of each other, are going to have identical physical properties. And so to separate them is impossible, at least separating them directly. Enantiomers with identical properties are inseparable. So what do we need to do? We need to turn them into diastereomers. And so we're going to abbreviate this one as RA for the acid. This is SA for the S version of the acid. To turn them into diastereomers, we're going to use a base that is enantiomerically pure. So it is only the R form of this amine base. When we react this mixture with this R form of the base, we now get two different complexes. We get the R acid with the R base. We'll put a kind of a dot here to show that that's a complex. And we make on the other side the RB with the SA. So I reverse those, but that should make sense, right? If we just put it on the bottom. The RB base with the S acid. Well, the relationship between these two complexes is that they are now diastereomers. And in the event that these complexes are solids, we can now do some form of recrystallization. So, for example, let's say that this one crystallizes first. We could crystallize it first. Now we would have pure RA, RB as its own solid. But the question didn't ask, how do we get a complex pure? We want pure A. Well, if we simply add base to this, that will free up the acid to give us our pure acid. Now, with this, to save time in the video, we did take some shortcuts. If you want full detail, make sure you check out the description of this process in the textbook.